Welcome to increasing and decreasing functions. So just a quick note, we have already talked about increasing and decreasing, and that's it, and the relationship between the derivative f prime. So we have already talked about functions increasing and decreasing. And the relationship with f prime of x. We are now just going to formalize what increasing and decreasing means and formalize the relationship. So first off, we just have to do quick definitions, what it means for a function to be increasing and what it means for a function to be decreasing. So a function f is said to be increasing on the interval I if for all a less than b with a and b and I, we have that f of a is less than f of b. So essentially, if you pick a larger x value, the y value should, or the function value should also be larger. A function is said to be decreasing on interval I if for all a less than b, where a and b are in I, we have that f of a is greater than f of b. So the function's decreasing if a larger x value leads to a smaller function value or a smaller y value. So what this means in terms of the slope. So if we think of secant lines, so first let's do increasing. So for increasing, if we take, again, a less than b with a and b in I, and we look at the secant line slope. So the slope of the secant line would be m is equal to, we would do f of b minus f of a all over b minus a. And we know that b minus a is positive, right? Since b is greater than a. And we also know that f of b minus f of a is positive, since we know that f of b is greater than f of a for an increasing function. So what we get then is that the slope of the secant line is greater than 0. And so if we picked a and b closer and closer and closer together, we would presumably get that the derivative was also positive. So from here, if we now let A and B get closer together, then if f prime of A exists, we presumably have that f prime of A is positive or is greater than 0. So this is again for increasing. So I'll just do that for f an increasing function. Now, if we do the same thing for decreasing, we do wind up. So if we did the same for decreasing, we would wind up getting, again, that if f prime of A exists, then f prime of A would be negative or less than 0 for f decreasing. So just sort of formalizing this, we have a test for where functions are increasing or decreasing. So for that test, we are going to suppose that f is continuous on the closed interval AB and differentiable on the open interval AB. Then we'll have 3 pieces. First, case 1, if f prime of x is greater than 0 for all x in the open interval AB, then we have that f is increasing on the open interval AB. Next up, if f prime of x is less than 0 for all x in the open interval AB, then f is decreasing on AB, the open interval. And if f prime of x is equal to 0 for all x in AB, then f is constant actually, I should change these. It's actually increasing on the closed interval. Oops, sorry. Derivative is greater than 0 on open interval. It's decreasing on the or increasing on the closed interval, and then decreasing on the closed interval. So we have increasing on the closed interval AB, decreasing on the closed interval AB, and then constant on the closed interval AB. This is where continuity really comes in to be able to extend to those endpoints as well. So this is sort of what we get, is we now have a formalized equivalency between increasing and the derivative being positive, decreasing and the derivative being negative, and constant and the derivative being equal to 0.